Hello, my name's Charlie Kepler. I'm an applications engineer and lead pilot here at Headwall Photonics, and today I'm going to walk you through the steps for taking your raw data after a hyperspectral mission and converting it to reflectance, along with generating your post-process SBET, SBET GPS file, and processing your LiDAR data to a digital elevation model if you have one. So the first thing I'm going to do is launch our Headwall batch process tool. And here we have the option for cube, flight, or mission. Cube is I'm going to do the operation on a single data cube, flight on a single directory, or mission on a set of directories. So for today, we're going to do the flight, and I'm going to browse to where my data is saved. And you're going to select that top level directory. And I'm going to choose the option first of SWR, which is Scene White Reference. Next, I'm going to click Process Flight, and it's going to pop up with a image of all of the cubes, the raw data before they've been corrected, and we can look through it and find out where our tarp is. If I zoom in, it looks like it's right here, and I'm going to double click on the tarp. Assuming you have the radiometric calibration data on your computer in your C Headwall sensor config folder, it'll automatically find it, and then it's going to take the cube which the tarp is in, which you double clicked on, and convert it to radiance, and then it's going to display this image here. I'm going to adjust my box size so that I fully fill the whole tarp, so it looks like I maybe need to go to about, we'll say 90. And now the whole tarp is being filled. I'm not classifying anything in the background or on the other tarp or on this little target here. And I'm trying to adjust my SAM spectral angle mapping threshold until about 70-ish% of the pixels are classifying as green. So I'm going to adjust this, make it a little bit bigger. And now maybe too many are going, so we'll dial it back a little bit. If you double click on a point and you want to change it, you can just click another point. So for example, if you clicked on a point that was a crease in the tarp or a section where there was dirt on it or something like that, you can always choose another one. And so maybe I'm going to say this looks like kind of a uniform area. I'm going to double click there. And that looks like it's pretty good. I'm getting most of the pixels, not quite all of them. I'm not misclassifying anywhere outside. So I'm going to call that a good average, and I'm going to say select reference profile header and choose the correct profile for this tarp, which I know to be this 56%. Once you're happy with that, you can say save scene white reference and close out. In here, you have the option of FTP downloads folders, so that's what you'll do to download data from your nano HPs or the VNear of your co-aligned HP system. We have the option of converting everything just to radiance, which typically is not done, but if you had a reason for wanting radiance data, you could do that. Otherwise, we will do this reflectance, RF, which in the process will create the radiance cube, then create the reflectance cube, and then get rid of the radiance cube so you don't have to use extra disk space. We also have the option of doing a spectral angle mapping model, band math, rename IGM, or AST to SAM model. So today we're going to do reflectance and process flight. This function will convert 18 raw data cubes to reflectance. Do you want to proceed? Yes. And it will take a little while. So while that is processing, we're going to open up POSPac UAV.